is our next question here. So this is GCSE final morning revision. We've had to switch from our other account because we've got the live got reported. So this one here is a diagram showing triangle ABC and triangle ADE. Describe fully the single transformation that maps triangle ABC onto ADE. So first of all, if the shape changes in size, we know it's enlargement. So our first step, if it changes in size, it's enlargement. Our next step is to find the scale factor. So as it says, describe the single transformation. There's 4 transformations. They are translation, enlargement, rotation, and reflection. If it says describe the single transformation, you can only pick one of those like command words. So you're going to pick one. So here clearly, as the shape has changed in size, it must be an enlargement. So once you give an enlargement, you must now give the scale factor. So our next step is to find the scale factor. So to find the scale factor, you always divide the new length by its corresponding old length. So to find the scale factor, you divide the new length by the old length. So to find the scale factor, you divide the new length by its corresponding old length. Well, it was ABC, the small triangle, onto ADE, the big triangle. So the new length is going to be AE, which is 1, 2, 3, 4, 4. Be careful of the scale. So therefore it's 4. Divided by the old length, well, the old length AC is just 1, and 4.1 is 4. So the scale factor is 4. You now got to find the center. So to find the center is always given as a coordinate, i.e. x, y. You go along the corridor up and down the stairs. So you match up corresponding vertices. Well, the new and the old of that triangle stay the same. If you match that with that and draw a line, it will go back to here, and that will go back to here. So all 3 lines will go back to this center here. It says my center as a coordinate, that's simply 1, 1. So for 2 marks, you must give enlargement. You must give the scale factor. The scale factor is what each length has been times by. So you divide the new length by the old length. So the scale factor of 4. And the center is where if you match up corresponding vertices and draw a line, they will cross, they will meet, and they meet here at 1, 1. So the center is 1, 1. The next one here is a Fibonacci sequence. So you've heard different types of sequences. This one is a Fibonacci sequence. So first of all, what does Fibonacci mean? Well, Fibonacci is where you add up the 2 previous terms to get the next term. So you can have it in numbers or you can have it in algebra. So here you can see that a plus 2a, that gives you 3a, the next term. 2a plus 3a, that gives you 5a, and so forth. So Fibonacci, you always add the 2 previous terms together to get the next term. So now it says the sum, so sum means add, the sum of the first 5 terms of this sequence is 2 to 8. So that's my first, that's my second, that's my third, that's my fourth. So I need to get my 5th term. So to get my 5th term, I always add my 2 previous terms together. So here I'm going to do 3a, add 5a, which will give us 8a. Because remember, you always add the 2 previous terms together. So as we're told the sum of the first 5 terms, I'm now going to add up my first 5 terms, because I've got my first, my second, my third, my fourth. I worked out my 5th by adding up the 2 previous terms. Add them up. So I've got a plus 2a plus 3a plus 5a plus 8a. And we're told here it comes to 228. So in your calculator, they're all like terms as they all end in a. If there's no number in front of the letter, the number is 1. So add numbers in front. So we're just going to do 1, add 2, add 3, add 5, add 8, press equals, and that comes to 19a. So we've got 19, lots of a, equals 228. 19a in algebra means 19 times a. The opposite of times by 19 is divide both sides by 19. 19 over 19 will cancel, joint leaves with a. And then 228, in your calculator, 228 divided by 19, press equals, is 12. So the value of a is 12, and that's a nice 3 marks. So just remember the word Fibonacci. Fibonacci is where you always add the 2 previous terms to get next term. So just write that again. So here we're told a, 2a. So you always add the 2 previous terms. So a add 2a. That'll give you next term. If there's no number in front, the number's 1. 1a add 2a is 3a. To get my next term, I'd add the 2 previous terms. So 2a add 3a. That'll give us 5a. My next term, 3a add 5a, gives you 8a, etc. Here, the sum of the first 5 terms, that's my first, second, third, fourth, fifth. Add those up in algebra. They all end in a, they're like terms. So 1 add 2 add 3 add 5 add 5 add 8 is 19 lots of a equals 2 to 8. Opposite times by 19, divide both sides by 19, and therefore you get a equals 12. So again, always make sure you're reading the question nice and carefully. Next one here is matching up graphs. So you could be asked to match up graphs depending on their shape, etc. So always look for key signs. So each of the equations in the table is an equation of one of these graphs. So here, the easiest graph to recognize is probably this one. You always look for the highest power. So y equals x squared. If the highest power is 2, therefore we know it's what we call a quadratic graph. So as teachers, think quadratic. If the highest power is 2, it's a quadratic. Think like a U. If it's a positive x squared, it's going to be a U shaped like a smiley face. So the only one that's facing up like a smiley face is that one. So therefore that graph has to be our positive x squared. So x squared is a U, it's a parabola. So therefore, as it's positive x squared, it's facing uphill. So it's a positive like a U shape, like that. That's the only one. That's our quadratic. That's graph D. If the highest power was 2, but there was a negative in front of it, there would be a reflection in the x-axis. So instead of being a U shape, it'd actually be an N shape, like so. So look out for the shapes. So that graph here is the only one positive x squared. That had to be graph D. Next one here, look out for the highest power. If the highest power is 3, y equals x to the power 3, x cubed. Therefore, we call that a cubic. If it's positive 3, you always read a graph from left to right. If it's positive x cubed, the graph slopes uphill with like a wiggle in it. So it goes uphill from left to right. It's like the snake coming out the ground. So this is our graph y equals x cubed. So x cubed, you always read a graph from left to right. Positive x cubed slopes uphill from left to right. It's like a positive snake. The graph is coming out the ground to say hello to you. So that's our graph C. So that's therefore y equals x cubed is C. Likewise, if the highest power is 3, but there's a negative in front of it, therefore it's still a cubic, but the negative means it's a reflection in the x-axis. So it's x cubed reflection in the x-axis. So instead of going uphill with a wiggle, it's going to come downhill with a wiggle. So reading from left to right, the graph goes downhill. So it's like the snake going back to bed. So that's my graph y equals negative x cubed. As a process of elimination, you've only got one graph left, which is called the reciprocal of x. So remember, reciprocal means 1 divided by. So x, reciprocal of x is 1 over x. The reciprocal of x is always bottom left, top right. So there's always a curve, the bottom left, top right. It never crosses the x or y axis. They're called asymptotes. So it gets very close. So the graph y equals 1 over x, the reciprocal of x is graph A. So if it was negative 1 over x, it'd be a reflection, it'd be top left, bottom right. But 1 over x is always bottom left, top right. So therefore, process of elimination, that has to be graph A. So make sure, look out for key signs, look out for the shape. X squared is a parabola, a U shape. Negative x squared, a reflection in x-axis will be like an N shape. X cubed, it slopes uphill from left to right like a snake coming out the ground. Negative x cubed slopes downhill from left to right, etc. So again, make sure you read the questions nice and carefully to see what shape represents. Next one here, we said graphs on, this one's quite tricky. So foundation and higher involving a cylinder. So there's 2 types. So make sure you read the question carefully. So here, it was worth 5 marks. It says Jenny has to cover 3 tanks with paint. So you've got to be careful here. She's covering the 3 tanks with paint. So foundation and higher. If you're covering a tank with paint, that means you're working at the surface area. So covering is doing the surface area. So it's not volume, what a lot of people thought. It's surface area because you're painting it, you're covering. If you're covering with paint, therefore you're painting its surface. So you're working at the surface area of the cylinder. She has to cover 3 tanks complete with paint. We're told each tank is in the shape of a cylinder and has a top, a bottom, and it has the diameter of 1.6 and a height of 1.8. How do you find the surface area of a cylinder? So again, it's up to you whether you've learned the formula or if you want to work it out manually. So surface area, you can see it's going to have a top and a bottom. Area, you can put your formula sheet. Area of a circle is pi r squared. As it has a top and a bottom, therefore, we're going to have 2 lots of pi r squared. That's going to be the area of the circle on the top and the area of the circle on the bottom. Because area of a circle is given pi r squared. Total surface area is going to have a top and a bottom, the tank. So it's going to be 2 pi r squared. You've then got to work out basically the wrap, the curve part. So if you think about it, it's like unwrapping a label from a can of beans or from a bottle of water. If you unwrap the label, it makes up a rectangle, doesn't it? So if you unwrap a label from a can, it makes up a rectangle. How do you work out the area of a rectangle? It's the length times the width. Well, the height of the can will be the width of the rectangle. Where does the label go around? The label of the can, it goes around this part of a circle, which is called the circumference. And you're given the formula for circumference is either 2 pi r or pi d. It's up to you. So you can use 2 pi r pi d. So to work out the wrap, it's going to be the length times the width. So it's going to be pi d times h. So you can learn that formula. So surface area cylinder is 2 pi r squared plus pi dh, or it's 2 pi r squared. Instead of having d, you can call d as 2 pi. Instead of having pi d, you can have 2 pi r, or you can have plus 2 pi r h. They're the same thing. I tend to use pi dh, the same thing. So surface area, because you're covering the tank with paint, you're going to work out the top and the bottom. That's area of a circle. So that's why you've got 2 lots. So area of a circle is pi r squared. 2 lots will be 2 pi r squared. The wrap, the label, forms a rectangle. To work out the area of a rectangle, it's length times width. The width will be the same height of the can, and h for the height, and the length of the rectangle goes around the circumference of a circle, which is 2 pi r or pi d. How do you work out area? Length times width, pi d times h. We're given all the information, so we're going to have 2 pi. The radius, we're told the diameter is 1.6. So the diameter goes from one edge of circumference through the center to the other side. So the radius is half. Half of 1.6 is 0.8. So therefore it'll be 0.8 squared. That's my first bit. Then plus pi dh. So leave the pi alone. Pi times diameter, we're told, is 1.6. Times the height, we're told, is 1.8. Does that make sense? That will give us the area. That will give us the surface area of one of the cylinders. So into your calculator, we can just type all into a calculator. So we've got 2 pi times 0.8 squared, plus here we're going to have pi times 1.6 times 1.8. Press equals press SD, and that comes to 13.06, etc. So that comes to 13.069, etc. You should copy the full number, only round at the end, and that will be in centimeters squared because surface area as the lengths. Oh, sorry, meters squared. Sorry, as the lengths are in meters, the surface area will be the unit squared. So meters squared. That's for one tank, though. That's for one cylinder. That's one tank. But what does she have? We're told Jenny has 3 tanks, so I've got to times that by 3. So 3 tanks. Therefore, will be 3 times my 13.06 number. So my calculator already has a number. So 3 times answer, press equals press SD, is 39.2, etc. Again, use the full number, it's 39.207 ... meters squared. What we're told here is we're told Jenny has 7 tins of paint. Each tin of paint covers 5 meters squared. And the total surface area of the 3 tanks, that came to 39. So has Jenny got enough paint? We know 1 tin covers 5 meters squared. So therefore, if 1 tin covers 5 meters squared, therefore 7 tins would be 7 times 5. And 7 times 5, that'll give us 35 meters squared. So she only has enough paint to cover an area of 35 meters squared. But the 3 tanks have a surface area of 39. So does she have enough? And clearly no. Why? Because what she has is less 35. You can write 2 ways. You can write 39 is greater than 35. So you can write no, or you can write 35 is less than 39. It's up to you. So has she got enough paint to cover 3 tanks? It says no, as she requires 39 meters squared, but she only has 35. So you can write 2 ways. You can write no, as 39 is greater than the 35 meters squared she has. So make sure you read the question carefully. Surface area, if she's painting something, it's surface area. Surface area of a cylinder is not given, but you can work it out fairly simply because you've got a circle on top, a circle on the bottom. Area of a circle is pi r squared. This is foundation and higher. So pi r squared plus pi r squared, that's 2 pi r squared. Then the wrap of a cylinder makes like a label, it makes a rectangle. It goes, the height of the cylinder will be the width of the rectangle, and the wrap goes around the circumference of a circle, which is 2 pi r or pi d, which you can just look at the formula sheet. So again, make sure you read the question nice and carefully. So it's really important you read the question. Next one here is inequalities and solving. So again, very likely you'll get question on indices. Some will be easier than others. So simplify c to the power 5. I'll write this out if you can't see it. So c to the power 5 divided by c squared. And here you've got d to the power 4 to the power 3. And here we're asked to write the inequality and then draw it. So first of all, if you're dividing and you've got the same base, laws of indices, you keep the base the same and you subtract the powers. So 5 subtract 2 gives you 3. That's the first one. So if we're multiplying, we add the powers. If we're dividing, got the same base, we keep the base the same and we subtract the powers. 5 subtract 2 gives you 3. If you've got a power raised to a power, you multiply the powers. So you keep the base the same, in this case d, multiply the powers. 4 times 3 gives you 12. Write down the inequality on this number line. So write down. So here, if you only got one circle, always write the letter. It doesn't have to be x, it could be any letter. So always make sure you read the letter. Here it's x. Which way is the arrow facing? So it's only got one circle. The arrow is facing to the right. So therefore you draw the arrow to the right. And you always, always, always put it above the number the circle's above. In this case, -1. Always check whether the circle is colored in. If it's an open circle, that's your answer. If it was colored in, you'd add an extra line to means it includes it. So here, x is greater than -1. You always copy the numbers always above where the circle is, like so. But you don't put the extra line because the circle is not colored in. If the circle was shaded in, colored in, you put the extra line to say x is greater than and equals -1. The next bit here, you're asked to draw it. When drawing an inequality, you always want the letter by itself. So you always want the letter. If you've got 2 inequality, you always want the letter by itself. So here, they were nice. They already go by itself. I'll show you one where they haven't. So if they're given it by itself, all you got to do is you start by drawing 2 open circles above the 2 numbers either side. So draw a circle above -3. Doink. Draw a circle above 4. Doink. You always draw circles above the 2 numbers as long as you've got the letter by itself. Now look at the sign. So here we had y is greater than, it had the extra line, -3, and less than 4. So the circles always go above the 2 numbers, always. But here, if it's got the extra line, that means you color in the circle. So you color it in, you shade it in. So on the left-hand side, -3, we're going to color in, because you can also include -3. You don't draw an open circle above -2, that's wrong. It's got the extra line, you still draw a circle above that, and you just color it in. Here, y is less than 4, so the circle still goes above 4. You don't color it in, and you don't put it above 3 colors in, and then you just draw a line connecting those, and that's it done. If it had something else in the middle, you got to do the same thing to left, right, and middle to keep it balanced. So does that make sense? Any questions? So transformations is the next one. So next one here, we only need to do the top one. The bottom one we've already done in a previous exam. So describe fully the single transformation that maps S onto T. So transformations haven't come up. So single transformation. So ignore this bit here. Single means you can only pick one. So basically you only pick one of the 4 types. There are 4 types of transformations. They are translation, enlargement, rotation, and reflection. They're the 4 types. So here, if it's the exact same size, facing the same way, it's a translation, because all you can do is you can really quickly check it. Trace paper is your best friend. So trace, it says the order is important, S onto T. So you're going from S onto T, you're going that way. The order is so important. So trace around S. Use a pencil in the ruler, don't use a pen like me. If you can move it, translate it left, right, up, or down, and it fits perfectly on top, therefore it has to be a translation. So if you can go from S to T by just moving it left, right, translating it left, right, and then up or down, therefore you know it's a translation. So 100% you know it's a translation. You can only pick one, so straight away these are out. So therefore, translation will get you 1 mark. Then you must give the vector. So to find the vector, so it's a translation by a vector is given as x over y. So it's not a fraction. There's no line in between. X represents whether it goes right or left. And it's the same as a grid. If it goes to the right, we can see x is positive. So if it goes to the right, it's positive x. If it goes to the left, it's negative, because negative x direction. Y is the bottom. If it goes up, it's positive. If it goes down, it's negative. So you pick a vertex on S and you map it to its same corresponding vertex on T. So I'm going to pick here. I'm going to pick bottom left. That must map to bottom left on T. You can't go from here to here. That's not the same vertex. So you're going to go, first of all, S. So you always do X first. So on X, we've gone 1, 2, 3, 4, 5, 5. Sorry, can't count. 1, 2, 3, 4, 5. And it's gone a negative X direction. So therefore, it's -5. Because it's gone 5 squares left. Be careful of the scale. Each square represents 1. So it's gone 1, 2, 3, 4, 5. And as it's gone to the negative X direction, it's gone -5 because its left is negative. So -5 on the top. Now that gets me to here. Now, how far has it gone up? So here, that gets me to here. It's gone up now 1, 2, 3, 4, 5, 6. Gone up. It's gone up. So it's positive 6. So -5, 6. And that's it done. So again, you can use trace paper. You can just count. So -5 to the left. Be careful of the scale. 1, 2, 3, 4, 5. Like so. And it's gone up 6. 1, 2, 3, 4, 5, 6. Fits perfectly on top. And that gets you all 2 marks. So just be careful today with transformations. Be careful which one they ask you. This one here is a bit trickier. So this one here, it says, describe the single transformation that maps triangle A onto triangle T. So first of all, we told you, if you were a second ago, there are 4 types. So there are 4 types of transformations. They are translation, enlargement, rotation, and reflection. Well, we said straight away, you can rule out translation because it says the word single. A translation, it says A onto B. So you're going from A onto B. Well, if you trace around A, for example, again, get trace paper, trace around A. A translation means you can only move it left, right, up, or down. Well, if you move it left, right, up, or down, it's never going to fit that orientation, is it? Because here you can see it's different orientation. So it can't be a translation. So now here, think rotation. Suppose people think rotation. So trace around A and then try a center. So we always recommend trying the origin first of all, 0, 0. So try the origin. So put your pen on origin, 0, 0, and try rotating it. So put a T at the top, so you know where you started. Each quarter of a turn represents an angle of 90 degrees. So here, put my pen here. So each quarter of a turn represents 90. So that'd be 90. Doink. Is that the correct shape, correct orientation? No. If you rotate again, doink, that gives you 180. which does it fit perfectly? No, but it's facing the right direction. So because it's facing the right direction, you know that's the correct orientation. So you know it's a rotation of 180 degrees. Because although it doesn't fit perfectly, you can see it's still facing the right direction. It's the same size, etc. So my first bit is I can say rotation. I turned it twice, so each quarter of a turn represents 90, so it's 180 degrees. If you go 180, it doesn't matter if you go clockwise or anti-clockwise, because 180 clockwise and 180 anti-clockwise are the same. It's the only one you don't put clockwise or anti-clockwise, but if you put 90, you have to say clockwise or anti-clockwise. Now you have to find the center, so you have to find the point. So about the point is always comma, x, comma, y. So go back to your shape. We know it's turning it twice, but we know what's wrong is we know the center's wrong. So we know 0, 0 is wrong, so just put a cross on that. So now try another point. So say, for example, you try -1, 1, -1, 0. So rotate again, 90 gets you to here, and then rotate 180. So does that work? Well, that works. I think that's perfectly for me. So here, let me just double check it. So I think the center, therefore, is -1, 0. So here, if I use a better pen, it'd be easier. So here, I rotated there, -1, 0, 90, and then 180. I think it fits perfectly. It's just the way my pen's gone. So that's my center. So as a center, as a coordinate, it's -1, 0. So always make sure you're reading the question carefully. So next one here. So a few more questions is the following. So a pie chart, again, is potential question for today. Again, there's no guarantees, it's potential. So just remember, there's a couple of ways. When you got a calculator, it's a lot easier. So always total the frequency, in this case, number of students. In this case, we're not told how many students we are. So we're going to add up our number of students. So we've got 56 plus 40 plus 24, and that comes to 120. So always total your frequency. In this case, 120. We know angles around a point, angles in a pie chart always sum to 360. So you've got 3 choices today. How do you get from 120? You want the angle here in degrees. So what do you times 120 to get to 360? Well, you times it by 3, because you could just divide 360 by 120 to tell you how much each person's worth. So each person's worth 3 degrees. So one way is just to work out how do you get from 120 to 360 times by 3, or you can just work out one person. Always divide 360, always put 360 on top by the total frequency, and that gives you 3. So each person is worth 3 degrees. Now you times each row by 3. So 56 times 3, that'll give you the angle. 56 times 3, that'll give you 168. 40 times 3, give you 120. And then 24 times 3 will give you 72. And again, you can always check it, because if you add those up, it will come to 360 degrees. How do you draw a pie chart? So if there's a line drawn for you, you always start by lining up the center of your protractor on the center as shown. So my first angle is 168. So put the center of the protractor on the center of your circle, center of the pie chart. Always align 0 on the line that's drawn, and you always measure on the outside. So my first angle is 168. So on the outside, get to 168, put a mark, like so, and then just join up from the center to the line. That's an angle of 168, and obviously label it, and then that's 168, and then label it as French. The next angle is 120. So now you rotate your protractor. So that was your center. That was my 0 line. Rotate it around. Your new line becomes your new 0 line. You can rotate the page if you want. So my new line becomes my new 0 line. So put the center protractor on the center protractor on the circle. On the outside, we're going to get to an angle of 120. So on the outside, get to 120. Put a little mark, and then just join it up. And then this angle here is 120, and then call it Spanish, etc. The last angle is 72. You could check it. You rotate your protractor around. Your new line is your new center, is your new 0 line on your protractor, and you can see it's roughly 72. And again, there will be a slight region of acceptable answers. So again, try to be as accurate as possible. So are we okay with that? The next one here is the following. So rearranging. So make a letter the subject. So make G the subject of the formula. So how do you make a letter the subject of the formula? For 3 marks. So make G the subject. So we've got to copy this out. So T is equal to the square root of G plus 6 all over 2. So you want to get G by itself. So before you can get that G, you can see the whole right-hand side is underneath the square root sign. So the opposite of square root is to square. So you technically did the same thing to both sides. So you're going to square everything on the left, and you square everything on the right. So on the left, don't change between lower and uppercase letters. So capital T squared. On the right-hand side, we know square root and square will cancel. because you're always in the opposite. Some people don't bother doing it to both sides because you know the opposite square root is the square root of the side, because on the left, you'll square it. T becomes capital T squared. On the right, the square root will disappear. Just level whatever's inside. In this case, g plus 6 all over 2. Now, go back to the question. That gets you 1 mark. It's worth 3. So the last question on foundation. So it's one of the first questions on higher. Although higher, you can also get more complicated, where you've got letter on both sides. Opposite divided by 2. Technically, you're timesing both sides by 2. 2 times t squared, so multiply the numerator on the other side by 2, becomes 2 capital T squared. On the right, you just left the numerator, in this case, g plus 6. Opposite add 6, you want to get g by itself, it's technically subtract 6 on both sides. So technically subtracting 6 on both sides. On the right, 6 take away 6 will cancel, leave us with g. Therefore, g is equal to 2 capital T squared minus 6. And that's it. So with rearranging, making less of the subject, you end up with something that looks slightly worse than what you started with, but that's just how it works. So rearranging, making less of the subject, you're just moving things left and right, always doing the opposite. So when you move a term over an equal sign, you always do the opposite. This one here, we'll do one more transformation. This one here was worth 3 marks. It says shape A can be transformed to shape B by a reflection in the x-axis followed by a translation. So shape A can be transformed to shape B by a reflection in the x-axis. So do that first. Reflection in the x-axis, you've got trace paper. So some people like to count squares, absolutely fine if you want to, or you can just use a trace paper. So if you use a trace paper, I've lost my trace paper now. I'll do it without trace paper. So here, A, first of all, you're reflecting the x-axis. So x-axis, x goes along, y runs the sky. So x-axis is our horizontal axis. So if it's 2 squares above, it's going to end up reflected 2 squares below. 2 squares above, 2 squares below. This one here was 1, 2, 3, 4, 5 above. So 1, 2, 3, 4, 5 below. But if you use trace paper, you could put trace paper over the shape, trace around A, fold in the x-axis, fold down, press hard. That's where my new triangle has become. It then tells me, followed by a translation CD. So if you were this earlier, we told you the top represents X, the bottom represents Y. X, if it goes to the right, it's positive. If it goes to the left, it's negative, the same as an axis. Y, if it goes up, it's positive. If it goes down, it's negative. So pick a vertice. I'm going to pick here the top left. That one there maps to here. So we're going to go 1, 2, 3, 4, 5, 6. It's gone the negative X direction. So therefore it's negative 6. Be careful of the scale. So it's negative 6. That gets me to here. And it's come down 1. So negative 1. So it's gone negative 6, negative 1. So just be careful. So 4 types: translate, enlarge, rotate, reflect. Here we're told to get from A to B, it's first of all reflection x-axis. So x-axis, x goes across, y runs the sky. So you reflect it, folds down. If it's 2 squares above, 2 squares below, 2 above, 2 below, 5 above, 5 below, that gets me to here. Now, how do you get from here to here? It's a translation. X comma by Y. If it goes to the right, it's positive. If it goes to the left, it's negative. So it's gone to the left, same as negative x directions to the left. 1, 2, 3, 4, 5, 6. It's negative x direction, so negative 6. And it's come down 1, negative 1. So my translation vector is negative 6, negative 1. And that's it done. So again, just make sure you're reading the question nice and carefully. Next one here, we've got question 7. So we've done this one's already come up before. Question 7. There are 10 boys and 20 girls in a class. The class has a test. The mean mark for all the class is 60. So first of all, another word for mean is the average. So the mean mark, another word for mean is the average. So if the average mark for the class is 60, how would you work out the total marks for all the class? So the total marks for all the class will be the number of students in the class. So there's 10 boys and there's 20 girls. So add up. So 10 add 20. Therefore, there's a total of 30 students. So 10 add 20 is 30. So it'd be the number of students 30 multiplied by the mean mark, the average that each student scored, in this case 60. And 30 times 60 will give us 1,800. That's the total number of marks for the whole class. We're now told the mean mark for the girls is 54. So the mean is the average. So the average mark for the girls is 54, the mean. So therefore, to work out the total marks for just the girls would be the mean they scored, in this case 54, multiplied by how many students are girls. Well, there's 20 girls. 54 times 20. That'll give us 1,080. So again, just use the calculator. So 54 times 20. That'll give us 1,080. That's the total marks for the girls. We want to work out the mean mark for the boys. So we now have the total marks for all the class. We have the total marks for all the girls. So to work out the total marks for the boys, we're going to do the total marks of the whole class, 1,800. Subtract the total marks, all the girls contribute, 1,080. And that comes to 720. That's the total marks for all the boys. We want the mean mark. So the mean for the boys will be the number of marks all the boys scored, 720, divided by how many there are. There are 10 boys in the class. 720 divided by 10 is 72. So again, just make sure you're reading the question nice and carefully. The next one here is you've got reverse percentages. So this one here, you've got reverse percentages. So I'll show you two ways. There's two ways to tackle this question today. So in a sale, the normal price of book is reduced by 30%. The sale price of the book is £2.80. Work out the normal price. So you've got two ways. So first of all, how do you know it's reverse percentages? Well, as we're doing percentages, we know 100%, percent means out of 100. So 100% represents the normal price. So when you go into a shop, the original recommended retail price is our normal price. Another word for normal is original. So that's our 100%. So I'll show you two ways. So as we're working out the normal price, therefore we don't know it. That's our normal price. We don't know it. So I'll show you two ways. What we do know is we know in the shop it had a sale and it's been reduced by 30%. Everyone loves when something's been reduced. It's getting cheaper. So it's been reduced, we take it off. We take it off its original. So 100 take away 30 is 70. So 70% of its original value is the sale price, which we know. The sale price is £2.80. I'll show you two ways. That's the sale price. Does that make sense? So if you think about it, so foundation and higher. So 100% is the normal. We don't have the 100%, so you have to leave it as question mark. If it's been reduced, you take it off the original. So 100 take away 30. So it's 70% of its normal value is the sale price, which we know is 2A. How do you get from 70% back to 100? Always divide by the number in front of the zero. So calculate power, divide by 7. That'll give you 10%. If you divide the left by 7, divide the right by 7. And that'll give you 0.4 or 0.40. How do you get from 10 back to 100? You just times it by 10. 10 times 10 is 100. And 0.4 times 10, that'll give you £4. So the original price of the book is £4. The other way you can do it, that's method one, is to think of it like a multiplier. So if you call the normal price of the book, the letter Y, multiplied by, it's been reduced by 30%. So 100% is a normal. If it's been reduced, we take it off. 100 take away 30 is 70. And 70% is a decimal. That would be 0.7 because percent means up 100. Divided by 100 is 0.7. So the price of the book times our multiplier of 0.7 equals the sale price, which we know is £2.80. Opposite of times by 0.7 is divided the side by 0.7. So £2.80 divided by 0.7. So £2.80 divided by 0.7, obviously going to get the same answer, in this case of £4. So Y equals 4. So Y equals £4 or 4.00. So just make sure you read the question nice and carefully. Next one here is a few questions on indices. So indices, again, bottom one's a bit more tricky. So question A, we've got m to the power 3 multiplied by m to the power 4. If you're multiplying and you've got the same base, you keep the base the same and add the powers. So 3 add 4 gives you 7. The next one, if you've got something in brackets, so 5np cubed raised to the power 3. Use your calculator. If you've got a number in brackets, raise that number to the power outside. So into your calculator, you can just type 5 to the power 3, which is 125, because 5 cubed is 125. Treat each letter separately, so each base. So if you've got, there's no power above a base, when the power is 1. So keep the base the same, in this case, n. If you've got a power raised to power, you multiply. 1 times 3 gives you 3. Keep the base the same, in this case, p. If you've got a power raised to power, you multiply. 3 times 3 gives you 9. Here, we're dividing 32 q to the power 9, r to the power 4, all over 4 q to the power 3 r. So if you're dividing, first we'll start by dividing a numbers at the start. Just put it into a calculator. So 32 divided by 4 will give us 8. So that's my first bit. Now look for the same base. Q to the power 9 divided by q to the power 3. If you're dividing, you've got the same base. You keep the base the same and you subtract the powers. Or 9 subtract 3 in a calculator gives you 6. Likewise, if you're dividing and you've got the same base, you keep the base the same. In this case, r. Dividing means subtract the powers. If there's no power above a base, then the power is 1. And 4 subtract 1 gives you 3. Again, you get the calculator to the hard work, the arithmetic side, but make sure you're answering each bit carefully as you go along. So that was that one. Next bit here. Just a quick few calculator things as well. So if you're writing a decimal as a fraction, you can just put it straight into a calculator today. So write 0.375 as a fraction. We can just type in 0.375, press equals, and it straight away tells me the answer is 3/8. Write down the reciprocal of 0.125. Well, reciprocal means 1 divided by the number. So reciprocal means 1 divided by the number. So 1 divided by 0.125. So you've got two ways. You can just type as a fraction. 1 over 0.125, press equals, and that'll give you 8. Or another way is you can type the number in, 0.125, and then press -1, same thing, reciprocal, and it's still give you 8. So reciprocal just means 1 divided by the number. If you're asked the reciprocal of x, it'd be 1 over x. The reciprocal of 0.125 is 1 divided by 0.125, which is 8. Write down the value of m to the power 0. Well, anything to the power 0 is equal to 1. You can't type the letter m into a calculator, but you can always type a number to check. So 9 to the power 0 is the same thing. Press equals, it still give you 1. Indices, if you've got a power raised to power in brackets, you keep the base the same. In this case, y. Power raised to power, 4 times -5 gives you -20. 1 mark, simply right or wrong. Again, if you've got something in brackets raised to power, you raise a number to the power outside. So in your calculator, you type in 2 to the power 5, which will give you 32. So you raise a number to the power outside. So 2 to the power 5 gives you 32. If you've got a power raised to power, you keep the base the same, in this case, x. Power raised to power, you multiply. 3 times 5 gives you 15. Keep the base the same. Power raised to power, you multiply. -4 times 5 into calculator gives you -20. Solving a linear equation, you want to solve for x. So find x, cover up. Move the -1 to the other side. If you move a term over an equal sign to the opposite, opposite -1, technically add 1 to both sides. -1, add 1 will cancel. So 2x over 5 equals 7 add 1 is 8. Opposite divided by 5 is to multiply the numerator on the other side by 5. On the left, just left the top, 2x. 5 times 8 gives you 40. 2x in algebra means 2 times x. Opposite times by 2. Divide both sides by 2. 2 over 2 will cancel. Don't leave as x. 40 divided by 2 gives you 20. Simplify. Be careful. Simplify. Simplify means you're collecting like terms. Like terms have the same combination of letters, including powers. So y squared plus y squared and y squared, they're all like terms, as they have the same base and the same power. Hence, you just add or subtract numbers in front. If there's no number in front, we know the number is 1. So 1 add 1 is 2, another 1 is 3. So you've got 3 lots of y squared. If you're multiplying, that's when you add the power. So if you're adding or subtracting, simplifying, you just add numbers in front, adding or subtract numbers in front. If you're multiplying, that's where you keep the base the same and add the powers. Simplify again, they all end in xy, so they're like terms. If there's no number in front, number's 1, but as it's negative in front, it's -1. So 7 lots take away 1 lot is 6, add 3 is 9 lots of xy. They're all like terms as they all end in xy. The next one, rearrange, make a letter the subject. So all we've got to do is find the letter we want. In this case here, we want the letter Y. So locate the letter Y. Where is Y? Y is here. Before you can get the Y, you need to get rid of this square root. So the opposite square root is the square to the side. So M now becomes M squared. And on the right, you just left whatever was inside the root. In this case, 3y plus p all over 5. Remember, the square root is gone because the opposite square root is the square to the side. We never like dividing. Opposite divided by 5 is to multiply the numerator on the side by 5. So we're going to have 5 m squared equals 3y plus p. I want to get y the subject. So find y, cover up. Opposite add p is subtract p from both sides. So 5m squared minus p equals 3y. Opposite times by 3 is divide both sides by 3. 3 over 3 will cancel. Don't lose at y. Y equals 5m squared minus p all over 3. And that's it done. We'll do one more before students have to go into exam. So we'll do a simultaneous equation. So this one here is quite nice today. The numbers can be really tricky, but it's really nice today because you've got calculators to do the arithmetic side. So when solving simultaneous equations, you match the numbers in front of x or y. Most teachers, we tell you to match up the numbers in front of y. As you got a calculator, it's so much easier today. So all you got to do, I'm going to times the whole top equation by the number in front of the other. Equation 2 is y. So I'm going to just times it by 5. So if you want to call it equation 1, equation 2, you don't need to. I'm going to times the whole equation 1 by 5. So basically times this whole equation by 5. So times that by 5, that by 5, and that by 5. You have to calculate do the hard work. So 7 times 5 is 35 lots of x. 8 times 5 is 40 lots of y. And on the right, just put in the calculator, 5.5 times 5 is 27.5. Like so. Now the bottom equation, I times by the number in front of the equation 2 is y. So bottom equation times by equation 1 is y. So in this case, I'm times it by 8. So I'm going to times that whole equation by 8. 11x times 8 will give us 80x. Negative 5 times 8 is negative 40 lots of y. On the right, I have 35 times 8, which is 280. Let the calculator do the hard work. Now it depends which one you matched up. As we matched up y, we're looking at the signs in front of our y terms. So look at these signs. It's only at this point you care about the signs. And then you remember an acronym. So whether you remember the word DAS, stop, or SSS, they're the same thing. So most students now prefer the word DAS. So what does DAS stand for? If you've got different signs, you add the two equations. If you've got the same signs, you would subtract the two equations, or you take them away. So here, so different signs we add. So different means you've got one positive and one negative in any order. Therefore, we're going to add the two equations. If they're the same, we'd subtract. So if they're both positive or both negative, you have to subtract the two equations. Here, they're different. We just add the two equations. So we add everything on the left and everything on the right. So 38 add 88, put in a calculator. So 35 plus 88, that'll give us 123 lots of x. 40y subtract 40y will cancel. And on the right, 27.5 add 280. That'll give you, press SD, gives you 307.5. The opposite times by 123 is divide both sides by 123. 123 over 123 will cancel, so it was x. On the right, 307.5 divided by 123 gives you 2.5. So x is 2.5. Now you've got x or y. You can now always substitute back into either of the two original equations. I'm going to substitute back into the top one. So we had 7x plus 8y equals 5.5. You'll always have worked out either x or y. So now I've worked out x. Every time I see x, so 7x in algebra means 7 times x. X is 2.5, so 7 times 2.5 plus 8y equals 5.5. In a calculator, 7 times 2.5, press equals, that comes to 17.5, plus 8y equals 5.5. I want to get y by itself. Move the 17.5 to the right, we're doing the opposite, which is subtract. 17.5 take away 17.5 will cancel. These are 8y. 5.5 subtract 17.5 gives you negative 12. Opposite times by 8, divide both sides by 8. 8 over 8 will cancel to give us y. Negative 12 divided by 8 gives you negative 3.2, or negative 1.5 as decimal. And that's your answer done. So appreciate we've got to get people into an exam now. So apologies we couldn't go live on TikTok. Like I said, no idea. So for now, best of luck today. Again, take it nice and slowly. It's your final exam. Make sure you show what you're working, and make sure you read the last bit about what you round each answer to. So round the answer to decimal places or significant figures. So for now, take care, stay safe. Best luck for today. Let us know how it goes. And apologies about the live not working on TikTok. So for now, take care, stay safe. Best of luck. Good luck. An exam does not define you. Try your best. That's all anyone can ever ask of you. So, look it out.